Normally, if you want to track the GPS location of a remote-controlled vehicle, you need to put a flight controller on the vehicle. The GPS connects to the flight controller, and then the flight controller does whatever it's going to do with that GPS information. Maybe it puts it in your on-screen display in your goggles, or maybe it sends the GPS coordinates back to your controller, and the controller displays or tracks those coordinates. But what if you've got a vehicle that doesn't have a flight controller? Most commonly, this is going to be a remote-controlled airplane, just standard servos and receiver, or a ground vehicle, a car or a boat. They typically don't have a flight controller. Today, I'm going to show you how you can use an Express ELRS receiver and a GPS unit to create a self-contained GPS tracking device for vehicles that don't have a flight controller, or really anything. That's pretty cool, isn't it? I got a complete track of my car's location throughout its entire trip. All I had to do was plug a GPS receiver into my Express ELRS receiver. No flight controller. Anything you could put this receiver and this GPS unit in, you can track the location of. I'm Joshua Bardwell, and you're going to learn something today. Everything we're going to do in today's video is made possible by this pull request: support directly attached GPS inputs to RX, and the key thing you need to know is that this is only available in Express ELRS 4.0 and newer. So if you're looking for an excuse to upgrade from your Express ELRS 3.x to Express ELRS 4.x firmware on your devices, maybe this is it. On the other hand, if you're not ready to upgrade yet, you're not going to be able to do any of the things that we're doing here. Now, I'm going to assume that if you're going to do this, you know how to update to Express ELRS 4.0, or maybe you want a different tutorial video to show you how to do that, and I'll put a link to that tutorial video down in the video description below. Suffice it to say, you're on Express ELRS 4.0, both on your receiver and your controller. Next, we need to think about what type of receiver you're going to be using for this project. And most commonly, you're probably going to be using a PWM receiver. So here is ER series ELRS PWM receivers. And the reason I say that is, if you're using a serial-based receiver, most likely you're using it with a flight controller. What else are you going to do with a serial-based receiver? If you have a PWM-based receiver, what we're going to do is we're going to take one of these PWM outputs and we're going to turn it into a GPS connection. So if you have a 6-channel receiver like this one here, and you have 6 servos, you're going to need to either get rid of one of those servos, or you're going to need to get a receiver with more PWM outputs. That's not to say that this can't be done with a serial-based receiver like this RP3 here. The thing you need to know is that the serial-based receiver only has one set of TX and RX pads. So if you decide that you're going to use that TX and RX pad to connect to a GPS unit, you can't use it to connect to a flight controller. In other words, it won't be able to do the function of sending your control signals to a flight controller. But hypothetically, you could do that if you want to make a standalone GPS tracker that all it does is track GPS of something that it's attached to, and it doesn't do any of the actual RC control stuff. Don't know why you would want to do that, because probably you could just get like a AirTag or something and do a better job, but it is something you could do. Keep in mind that a few Express ELRS receivers like this XR4 have an extra UART. Notice here we've got the TX and RX pads, and we have a second TX and RX pad. In that case, we could connect a GPS to that second TX and RX pad while still doing our main control signals on the main one. For this demonstration, I'm going to be using the ER3CI receiver. In real life, that probably wouldn't be a great choice. It's only a 3-channel receiver. If I use one of those channels for GPS, now I'm down to 2 channels. And yeah, I guess technically you can do a car or a boat with 2 channels, but it really doesn't leave us a lot of room to work. Nevertheless, everything I'm going to do with this receiver should be exactly the same as what you do with yours, except you might just have more channels to work with. Hopefully you can extrapolate. The first thing we're going to do is we're going to put the receiver into Wi-Fi mode, I'm just going to select Enable RX Wi-Fi from the Express LRS Lua script, or I could just wait for 1 minute of the receiver being powered up without a connection, and it would go into Wi-Fi mode automatically. I'm then going to connect to Express LRS RX Wi-Fi network. The password for that is Express LRS, all lowercase if you've never done it before. And after I have connected, sometimes the Express LRS configuration website will pop up automatically. Most of the time, in my experience, you have to do it manually, and you're going to do that by opening a web browser and typing 10.0.0.1. This is the web interface for your Express LRS receiver. And what you're going to do is go down to Connections. And in Connections, you're going to see 1, 2, 3 outputs or more, depending on how many outputs your receiver has. So if you have a 6-channel Express LRS receiver, you may going to see more of them. I only see 3 because I only have 3 outputs. And what you're going to do is you're going to set one of those to serial TX and serial RX. Now I've already done that. So mine originally was set to 50 Hertz. This is what it looks like when it's set to PWM output. We're just outputting channel 1, 2, and 3 on pins 1, 2, and 3. I'm going to change that to serial TX, and you'll notice when I change pin 2 to serial TX, pin 3 automatically changes to serial RX. You may have some restrictions. For example, I don't know for a fact that you'll be able to set any pin you want. If you've got a 6-channel receiver, you may not be able to set any pin you want to serial TX or RX. I don't know because I don't have every single receiver that is out there. But you're going to choose one pin and you're going to set it to serial TX. Another pin will then automatically be set to serial RX, and you're going to hit save. And I want you to take note of which pin is serial RX because we're going to need that later. So in my case, that's pin 3. Then you're going to go to serial, and you're going to set serial 1 protocol to GPS. Although, if you have like the XR4 receiver that has multiple UARTs, you could have serial 1 set to Crossfire, that's the default, and you may be working with serial 2. See here, this is UART 2 because it says TX2 RX2, and then by default, this is always UART 1. But basically what we need is we need a UART set to GPS, and we need serial TX and serial RX here set on some pin. Once you've done that, we're ready to wire up the GPS and the receiver. As far as wiring goes, first of all, this servo plug here is just for power. We have a 5-volt voltage regulator here just to power everything up. And this wire here is for battery voltage sensing. So that's not really related to the GPS in any way. The key thing that we need is that we have the TX wire from the GPS, and that is this yellow wire here. The TX wire from the GPS is going to the signal pin on whatever the RX channel is on the receiver. So again, if we go back here to the web UI, we see that channel number 3 is the serial RX, and you can see that I've got the white wire, that's the signal wire for channel 3, going to the TX pin on the GPS. You'll also notice that the RX pin on the GPS is completely disconnected. At this time, Express LRS communication with the GPS is entirely one way. The GPS sends the positioning data, that's it. The receiver doesn't send any data back to the GPS. And that's relevant because if you do implement bidirectional communication to the GPS, you can do things like a Betaflight flight controller or an iNav or an ArduPilot flight controller will configure the GPS to optimize its settings for whatever it is that they're doing. They'll update the refresh rate, they'll change the baud rate, and so forth. If you haven't set those things manually, the flight controller can do it for you. In our case, we're going to need to set the settings, most specifically the baud rate for the GPS, manually a little bit later in the video. But for now, at least, the RX wire on the GPS is not used at all, and you only need to connect to the RX connection on the receiver. Now, at this point, it might work, but it probably won't work. And the reason for that is that Express LRS currently only supports NMEA protocol, not U-blocks. And that's usually not a problem because most GPSs today support both NMEA and U-blocks. But the other thing is that Express LRS only supports a baud rate of 115/200 baud. And many GPSs default to 9600 baud or something other than 115/200 baud. So at this point, I'm going to show you how to set the baud rate manually because I'm going to guess that most people are going to have to do that anyway. Although if yours is just magically, well, how would you even know if it was magically working? I haven't shown you yet. Let's set the baud rate just so we know how to do it. And we're going to set the baud rate using this software. This is uCenter, and it is GPS configuration software for the GPS devices like this. You're going to want to download uCenter 2 and install it. In order to connect the GPS to the computer, we're going to need an FTDI adapter like this. They come in many different forms. I like this one because it has these pins broken out and they're labeled clearly, so it's really easy for me to know how to hook it up to my peripheral. It also has a switchable 5 volt and 3.3 volt option in case whatever you're using doesn't take 5 volts, it can output 3.3 volts. It's a nice thing to have. And what I like to do is just take a servo extension cable like this and take the servo plug off one end, so I can take this wire that's coming from my GPS and I can plug it in. And so now I have power, ground, and signal. And oh, I am going to need bidirectional communication for this, so I'll need to hook up that 4th wire. And then we're going to take ground. VCC is voltage, or 5 volts. This is the TX coming from the GPS, so it's going to go onto RX on the FTDI adapter, and this is the RX coming from the GPS that is not used, but here we're going to use it. We're going to connect it to the TX on the adapter. Well, apparently uCenter 2 has a whole bunch of like login, create account BS. Unfortunately, if you have an M10 GPS, you have to use uCenter 2. You cannot use uCenter 1, which is, as far as I recall, didn't have any of that nonsense. If you happen to be using an M8 or M9 GPS, you could download uCenter and not deal with that. So let's go ahead and plug in the FTDI adapter, and we see here device added COM3. That's very good. If you don't see that, there may be a set of drivers you need to download and install, and that'll just depend on what FTDI adapter you bought, and hopefully it came with instructions for how to install the drivers. We're going to click data sources here in the upper left, and we're going to click plus, add a new data source. We're going to select that COM3 that just popped up, and then you can just hit detect baud rate because it'll auto detect the baud rate that your GPS is at, and that is probably the way that is most likely to work. We hit add device. It's going to scan through the baud weights to try to find a one that's a correct baud weight, and once it does, it will connect and begin reading information. And you can see here it's already showing satellites that it sees. I probably won't get a GPS lock because I'm indoors, but it is communicating with the GPS. And if we go to consoles, we can actually see messages coming in here. This is the GPS. We just see them scrolling up. The time stamp keeps incrementing. This is the GPS talking, and that just confirms that like we're talking to the GPS. Here's the change that we need to make. We're going to go to Tools and Services and Device Configuration. And here in the search bar, we're going to type CFG-UART1. And here for CFG-UART1, we're going to go to the baud rate option, and we're going to put in 115200. And then we're going to write to layer RAM and flash and set, and then send. Now, I'm not able to do this right now because I'm using an M8 GPS. I just reached in a drawer and grabbed the nearest GPS I found. It turns out it was an M8 GPS, not an M10. So I am going to have to go back to the old uCenter app, and I guess as long as I'm doing it, I'll show you how to do that as well. In the old app, we are going to click here and select the COM port, and I don't believe there's an auto baud option, so you may need to do some trial and error to find the correct baud rate for your GPS. In my case, mine is already set to 115200, and when I select that, and you can see I've got green here, I'm connected, it starts reading and talking to the GPS. Likewise, if I do view messages view, I can see if I do view packet console, there we go. I should be able to see data coming in, verifying that we're talking to the GPS. What I actually want to do is do view messages view. Once I've opened the messages view, I'm going to scroll down on the left to find UBX and double click to expand. config and double click to expand, and then PRT ports. And what we want to do is we want to change the target UART1. We want to change the baud rate to 115200. After making that change, we're going to click the send button, and that will write that change to the GPS. At that point, you will lose communication with the GPS unless your GPS was already on 115200 baud rate. So then go up to the baud rate selection and change it to 115200, at which point now the software and the GPS should be in agreement about the baud rate, and you should get connection back. And you can again confirm that just by looking at the messages here. You should see the messages scrolling in. Now at this point, the GPS is on 115200 baud rate, but it will not stay there if you power cycle. The way that we write this to permanent memory is we go UBX config and config, CFG. And we want to select save current configuration. We want to make sure both BBR and flash are selected, and we're going to hit send, and that will write that change to the permanent flash memory. At this point, let's test that this worked we're going to unplug the GPS. We're going to plug it back in again. We're going to reconnect, and we should see that we reconnect at 115200 baud rate. So if I go View, Packet Console, I should see those messages coming in, and since I just power cycled the GPS, I know for a fact that it is now staying at that 115200 baud rate through a power cycle. That's all we need to do. Now we'll plug the GPS back into the receiver, and here's how you can verify that this is actually working. In your EdgeTX radio, press the model key or the menu key, and you're going to page to the telemetry screen. Now, if you've never done this before, you may need to discover new sensors. However, if you have previously used your radio with a GPS drone, you may have already discovered the GPS sensor. You can go to the sensors list here, and if we just click the jog wheel on this down arrow, it will expand the list, and we can see here all of the telemetry sensors that are coming in from the receiver. This flashing star means the sensor is currently being updated. If I scroll down, I should see at the bottom GPS, and notice that the GPS sensors are being updated. We see the flashing star here periodically. They're not blank, and they're not missing. If they're missing, just go up to the top of the list and discover new sensors, and it should discover them. But in our case, this confirms that the Express ELRS receiver is getting GPS telemetry from the GPS unit. Now, it's not getting any information because the GPS doesn't currently have a lock because we're indoors. But as soon as we take it outdoors and get a GPS lock, that information will start to show up. But what can we do with that information? The next thing I want to do in this video is I want to show you some clever ways, like just having GPS coordinates in telemetry isn't that useful. I want to show you some clever things we can do with this information to store it, to save it, or maybe even show it like on a live map. But before I do that, I want to pay the bills. And the way I pay the bills is not by reading you an ad read or sponsor read. No Squarespace, no, what is it? Viore clothes. These are all just podcasts and other things I listen to. Nope. I'm going to ask you to join my Patreon. Patreon is a website where you subscribe to me. Don't give your money to Squarespace or Viore or Airbnb, God forbid. No, give it to me. Because all I want from you is $2 a month. I mean, I want more, but I'll take $2 a month on my Patreon. Am I worth $2? That's less money than it's ever been, and yet I haven't raised my prices at all. Man, I'm a fool. There's a link down below. Please join my Patreon. I make great content. You love my content. No? You tired of this? Okay, let's just keep watching the video, and I'll try again next time. So the next question is, what can you actually do with these GPS coordinates once you've got them? And we're going to start from the simplest and easiest and arguably least useful up to like the most sophisticated and coolest, including that thing I showed you at the beginning of the video where you've got like a live map tracking your vehicle. As I said previously, the first thing we need to do is we need to make sure that the telemetry is being reported. I'm going to do that by pressing the model or menu key, and then I'm going to page to the telemetry screen. There we go. Now it's showing up. So what can we do with this information? Because this isn't very useful. 3554 north, that number one, that's not very much precision, and you don't want to just go in there and look. And in fact, when it powers down, it might go away. So here's a simple way to get these GPS coordinates on screen. I'm going to press the model key, and then I'm going to page left to the display screen, and I'm going to go down. You can see screen 1. I've already got some stuff on screen 1. What is screen 1, screen 2? You'll see in a second. So I'm just going to go to screen 2, and we're going to change that to nums, and we're going to go down, and we're going to make the first one. I'll click, and then I'll just long press the jog wheel and go down to telemetry. And I like to make that one be the number of satellites. Almost there, almost there. There we go, sats. And then the second one, again, long press the jog wheel. We'll go to telemetry. And this one is going to be, there it is, GPS. And here's what that lets us do. Just going to back out to the main screen. If you then press the telemetry key on your radio, and we'll page to page 2, we can see the GPS coordinates and the number of satellites with a little more detail. And that's fine, but there's still more we could do. Hold on though. That's how we do it on a black and white screen radio. On a color touchscreen radio, you would instead create a widget. And the widget would be a telemetry widget, and it would show up on screen. And you can actually have that sort of floating on your main screen. You don't even need to press telemetry or anything. I've got a full tutorial about how to set up widgets in EdgeTX. I'm going to link it below. It's a deep and complex topic with a lot of capabilities, but a little bit too much to go into in this video. But let's think about how we're really going to use this. What's going to happen is, most likely you're going to crash the drone. And you're not going to know where it is, and you're going to want to use the GPS coordinates to find out where it crashed. And so wouldn't it be nice if there was an easy way to just get to Google Maps from this telemetry? Haha, there is. This is a Lua script that can run on your radio that makes a QR code from your GPS telemetry. So we're going to go to release 1.0, and this is a traditional regular black and white screen radio. If it's an OLED, you would choose GPS QRL or QRI, I for inverted. Since this is not an OLED screen, it's an LCD screen, we're going to use GPS QR.lua. And what we do is we plug the radio into USB, and we select USB storage. And then you're not going to put this where you think you're going to put it. What we're going to do is we will right-click, Save Link As, and we're going to save it in scripts, yes, but not tools, which is where you would normally put a Lua script. We're going to put it in telemetry, scripts /telemetry, and save there. Then unplug USB, and we will press model and page to screens. And let's just make this screen 2. Screen 2 is going to be script, and GPS QR is the only script that's available there. And then just for completeness, I like to know the number of satellites. I do like to be able to check the numsats without actually, well, we don't have a on-screen display on this car. We don't have an FPV system at all. So we're going to go telemetry, and I will just put sats down here on my first screen. There we go. And that way, here's how that works. What I do is I press the telemetry key, tele, and it generates a QR code for the lat and long that is on the screen. And then if I just take my phone and scan that QR code and hit view on map, oh, hang on, I have to unlock, and boom, it takes you on a map view to exactly that location, as well as showing you the lat long with a little bit more digits if you want to type them in. And then if I go to my main screen, sats 12, I can still see the number of sats, so I know that I have lock before I start driving my car around. Now that's pretty cool. But there's even more that we could do. Because wouldn't it be nice if I could literally track the location on a map in real time? Well, we're not going to do that with an EdgeTX radio, but we can do it with a laptop or an Android tablet, or maybe an iPhone tablet, I'm not sure. I'm going to show you two different ways to track your vehicle's location on a map. One of them is free, and one of them is a paid service. One of them is a more sort of generic app that does a lot more than just track your vehicle's location on a map, and one of them is more like focused specifically on FPV stuff. We're going to start with the free one, and the free one is an app called ATAK, the Android Tactical Action, I don't know what it is. ATAK is available from the App Store, but don't go download it from the App Store. And the reason being that the version that we need is not the latest version. The version that we want, first of all, you get it from tak.gov, tak.gov, and the version that you want, the latest is 5.7, but you want 5.6. And I'll tell you the reason for that in just a second. So you're going to download the 5.6 APK. And then you're going to go to the plugins page, and you're going to search for the UASTool UASTool plugin. And here it is, UASTool. You're going to also download the UASTool plugin. You will need to log in. You'll need to make a login to download this, but it's easy and free. Next thing you're going to do is you're going to install the ATAK app, and then you will import the UASTool APK. You do not just run the APK as an installer like you would normally do. I'm going to suggest you go check out this video, which I'll link in the video description below, which takes you through the full install and setup for both ATAK and UASTool. ATAK is a pretty sophisticated app, and installing it is not as simple as just click go on the APK. You're definitely going to want to follow the tutorial. It's not complicated, but there are some things you need to do in a certain way in order for it to work correctly. The most basic thing that ATAK does is show you a map and show you the location of yourself and other members of your team on the map. In my case, there are no other members of my team, it's just me. But it can also show you other tracked devices like vehicles or drones. That's what the UASTool plugin is for. In order to use it, though, we need to get our location information into the ATAK app. Here's how we do that. On your radio, you're going to press the sys key, and then you're going to page to the hardware screen. You're going to scroll all the way down to the bottom, all the way down, and find the USB VCP setting. Now that is set to CLI, and that is what you need in order to be able to flash your Express LRS module. When you flash your Express LRS module via USB pass-through, that's what makes that possible. When you change this setting, flashing of your Express LRS module in your radio via USB will no longer work. You'll need to change it back. You can still flash it via Wi-Fi, right? But you can't flash it via USB if that's something you do. We're going to change this from CLI to Telemetry Mirror. And what that's going to do is it's going to make the radio output the Crossfire telemetry data via the USB. Then we're going to plug a USB cable into the USB port on the radio and plug the other end into the Android tablet. When we do that, this pop-up will appear and we will select USB VCP. Okay, well, I can't figure out how to delete it. All right, well, anyway, what you're going to, what if I do that? No. What you're going to do is you're going to hit the plus right here. You're going to select platform is Crossfire ArduPilot. I know this isn't ArduPilot, but it's Crossfire, and that's all that matters. And monitor mode is serial. And serial device is your radio. And baud rate is 115200. And then you can actually show a camera feed from the aircraft if the tablet has access to it. We do not, but theoretically we could also get a feed if we had like an HDMI capture card. If you had an HDMI capture card plugged into your Android tablet and it was capturing your video feed, then you could display the feed here in ATAK as well. We're just going to leave that set to none, and then you'll hit OK, and it will show up right here. There's a lot you can do at that point. If this was a DJI drone, we could literally fly the whole drone from within ATAK if we wanted to. If it was an ArduPilot drone, we could use ATAK instead of Mission Planner to fly the drone. But one of the things you're going to do is you're going to want to tap on the aircraft. And this one right here is the breadcrumbs. So if you just tap that, it'll turn on breadcrumbs and it'll track the location of the device. You might also want to tap this one here, which will lock on the location of the device and have it follow it around the map. And that app that I want to show you is called Squirrelcast. And as you can see here on this YouTube video, not only, let me pause it here, not only does it show telemetry of your drone in flight, it shows a live track of your flight path. And if you're doing DJI, it can actually stream your video straight from the goggles and show it all on one screen. Very cool. It's really optimized for DJI as far as I can tell, but it, obviously if all you want to do is track the location on a map, it could do that. The cool thing about Squirrelcast is that it uses your Express LRS backpack, which is built into your radio to broadcast the telemetry data. So you can connect over Wi-Fi. You do not need to plug in a USB cable, and you don't have to download this ATAK app and do all that nonsense as well. However, I couldn't get it working, and I found like 4 different things I did wrong, and then I fixed them. And finally, I got to the end of the troubleshooting process, and as far as I can tell, I've done everything right. I've gone through all of the steps, everything's on the latest firmware, and it's not working. So rather than show you 15 minutes of me failing to get it working with no payoff, I'm just going to say, hey, Squirrelcast, you look cool. I couldn't get you working. You know it exists. It's going to cost you $7 to try it out, and then it might not work like it didn't work for me. So if I were a more patient person, I would reach out to the Squirrelcast devs and get them to help me out. I'm sure they'll respond to me after this video goes out. But in the meantime, I'm going to just say, hey, Squirrelcast exists. It looks pretty cool. It didn't work for me, and I don't know why. Attaching a GPS to your Express LRS receiver is just one of the cool things that Express LRS 4.0 can do. I've got a video with an overview of all the new features in Express LRS 4.0. I'm going to put a card on screen to that and a link in the video description below. The next video I'm about to start making shows how to use an Express LRS receiver to arm and disarm your DJI Air unit. So your Air unit will go out of low power mode even if you don't have a flight controller. That's just one of the things that's in Express LRS 4.0, and there are many others. Here's a link to that video, card on screen, and I will see you in the next one. Woo, smooth outro, Bardwell.